Today we're going to be looking at the stoichiometry calculations on page 18 of your booklet. Now, everything that we have done up to now has brought you to this point, grade 10s. You are now going to be applying your mole concept. You're going to be applying your fully balanced chemical equations. You're going to be applying percentage composition, empirical formula, as well as mole ratio. There is going to be everything that you have learned up to this stage. Writing of chemical formulas, naming of compounds. Everything is going to help you with this last section of chemistry. So we've got a picture in front of you here where we've used the chocolate chip cookie recipe example, and we've shown you that with this picture shows you that when you have a certain amount of reactants or ingredients, you are going to produce a certain amount of products, and that is what stoichiometry does. It looks at the numbers of things or numbers of substances that are required for a certain or desired product number or a desired reactant number. So vice versa. Everything is proportional. Everything is within ratio. So if I want 1 cookie versus 12 cookies, that is going to influence the number of ingredients or reactants I have. And the same analogy can be applied to your chemical reactions. I want you to think about, and this analogy is used quite often, I want you to think about a car factory. Okay? If you have got 20 wheels for a particular car and you've got 5 car bodies, how many cars are you going to make if 4 wheels fit 1 car body? Think about it. Okay? You should only have 5. 5 cars is what you can make. Now, if I have 25 wheels and I have 5 car bodies, what's going to happen? I'm going to have leftover wheels. Or if I have 20 wheels and 4 car bodies, I'm only going to be able to make 4 cars, not 5. Can you see where I'm going with this, grade 10s? It's all about having enough reagent or enough reactant ingredients to assist with the actual product, the desired product. Okay. It's all about composition and reaction. I want you to just keep that in the back of your mind before we carry on to the next slide. Okay, so now we are going to make sure that you're on page 18 of your stoichiometry booklets. Now we're going to be looking at what we call mole ratio. I've mentioned it before, but now we're going to look at it in a little bit more detail. And I want you to look at these pictures that are in front of you. And as I'm speaking, hopefully it all comes into play for you and you can see what I'm talking about. Right. When you know the ratio of substances in a reaction, it is possible to use the stoichiometry to calculate the amount of either reactants or products that are involved in a reaction. And that has got to do with mole ratio. We use the mole ratio to actually work out the mole value. We use the mole ratio to work out how much reactant I need or how much product I need. So in essence, that mole ratio, think about back in grade 9 when we used coefficients, which speaks about the number of molecules. That mole ratio is got to do with the coefficient. Okay, the coefficient is the mole ratio. So the picture at the bottom shows the reaction of magnesium and oxygen. And it shows the coefficients in front of each reactant or product. You can see the ratio there is 2 to 1 to 2. That is the ratio. Okay, just bear that in mind. And that ratio, if I increase one of the reactants or one of the products, then I'm going to have to go up or or increase the other ingredients or the other reactants in the reaction to comply with that. Because it has to be balanced at all times. It needs to adhere to the law of conservation of mass. So keep that in mind, and we're going to look at how this mole ratio, how we can practice this, and how we can determine how much we need of a certain ingredient or reactant when we change something in a chemical reaction. An example of this mole ratio, of how we use this mole ratio, has been placed on page 18 for you using ammonia. The first line shows an unbalanced chemical equation. It shows the nitrogen and shows the hydrogen, and then it shows the product of ammonia. But there are no coefficients added. It's unbalanced. Please write that in on your page. The second row with the purple coefficients are balanced. That is a balanced chemical reaction. Everything is stable. Everything is conserved. Now, when I change the ratio in that balanced chemical reaction, it's going to be 1 to 3 to 2. That is my mole ratio for this chemical reaction. Now, if I go and I change something and I add 3 to my ammonia, now I've gone up by 3. I've times this by 3. How is this going to impact everything else in my chemical reaction? Now I need to change everything else in my chemical reaction. So now my hydrogen, instead of it being 3, it's going to be 9. And my ammonia, instead of it being 2, it's going to be 6. And how do you determine this, grade 10s? So let's look at the 3 there. That 3 has been added in. All of a sudden, I'm telling you the ratio is 3. Okay? I'm going to divide up, and I'm going to multiply across to determine this ratio when there's a change. So 3 divided by 1 times 3 is 9. 9 divided by 3, okay, times by 2 is 6. That is how we work it out. Let's look at the next row where they've gone and they've added 10 as a ratio for the hydrogen. How am I going to work this out for my nitrogen and my ammonium? What is the ratio now? 10 divided by 9 times by 3 is 3.33. Okay, 10 divided by 9 times by 6 is 6.67. The same can be said for the last example where the ratio is 3.5. So can you see how by changing the ratio or the number of moles in one product or one reactant, it's going to influence the entire recipe. If you want to think of cooking or baking, if you're going to, instead of making a dozen bread rolls, now all of a sudden you want 2 dozen, you're going to have to double up on everything. And the same principle works in chemistry. Depending on what your desired product is, how much do you want to create, you are going to have to change the ratio. Okay, so grade 10s, there are 2 new concepts I want to introduce you to. I don't want you to stress too much about these 2 new concepts because in grade 11 we go into a lot more detail regarding this for stoichiometry. These 2 are limiting reagent and excess reagent. And what are these 2? These 2 are 2 sides to a coin. Okay, when there's a chemical reaction, sometimes there's often too little or too much of a substance. Okay, and in many situations we have to know which one is going to be the substance or the compound that's going to run out first, and which one is going to be in excess, so we can determine how much product we want, or we can play around with the recipe. So the 2 definitions I want you to have a look at, and I want you to write them down, is the limiting reagent, which is the reagent that is completely used up in a chemical reaction. So this is the thing that gets finished first and usually stops. It actually gets the chemical reaction to equilibrium. It's the reagent that causes the equilibrium because it runs out first. Then there's the excess reagents. This is the reagent that is not completely used up in a chemical reaction. I don't want you to stress about these two concepts because we're going to go, like I said before, in more detail, but I'd like you to write them down. I'd like you to know of them, please. In your books, we are using examples without a limiting reagent. However, some of the reactants will be in excess, and we will tell you which ones are in excess. I do believe that you will only be required to identify which reactant is in excess in grade 11. We don't do that now. Okay, just please write this down and then we'll start going into two examples of stoichiometry. And I'm going to show you the 5 steps that you need to know off by heart and that are going to really, really help you with any sort of problem that we throw at you. At the bottom of page 18, the first example that we have, and it's written in a nice little story form for you, and that's why I would suggest that you have a highlighter or you have a little pencil with you when you read these little stories so that you can identify exactly what's going on and exactly what you need to work out. Because at the end of the day, we're going to be asking you either for mass, we're going to ask you for concentration, we're going to ask you for volume, and depending on how we've worded it, you are going to have to identify certain things. So the first thing, let's look at this example. It says there, what volume of nitrogen gas will be formed if 10 grams of ammonia is burned in excess oxygen to form nitrogen, gas, and water? So what do they want here? They want a volume. That's at the end of the day. That is the essential question. They want to know what is the volume. And that comes to step 5 later on. Okay. The first thing you're going to do is you're going to write out the balanced equation. So I've added some red lines here. And the reason why I've added the red lines is depending on what they're asking for, it's nice to just keep it in columns. Then it helps you structure the problem. You don't have to do this, guys. I just think it's a nice trick. It's a nice way of keeping everything together. You're going to write out a balanced equation. You're going to circle the thing that they're asking about. What is the reactant that has got a mass? In this situation, it is going to be ammonia. It's ammonia. When ammonia is burning in oxygen. And they give you the amount of ammonia, they say 10 grams. So in step 2, you are going to write what you've been given underneath the relevant reactant or product. So you've been given the 10 grams. So write that down, 10 grams. Step 3, you're going to convert this given mass, volume, or concentration to mole. So this is your mole calculation here. And this is why we gave you those 3 different formulas, because depending on what we give you, it might not be mass, it might be a volume or a concentration, and then you have to use the relevant formula. In this example, it's just your default mole application, and you should get an answer of 0.59 moles. So write that in. Pause this video if you haven't written everything in yet, and then we'll go to step 4 and 5. Okay, now step 4, this is where the mole ratio comes into play. And here you're going to use your divide up and multiply across. Okay, because you have the moles for your your ammonia. You have the moles. So from that and from your coefficient, which is 4, you can work out the moles of the other reactants and products using the divide and multiply. So I take 0.59 and I divide it by 4 and times it by 3, I'm going to get 0.44. I do the same for all the others all the way across. And the last thing you're going to do, once you've got that, you've got your moles and you've got your mole ratio for everything in your chemical reaction, is you're going to use that mole ratio to work out the required mass, volume, or concentration. In this example over here, they wanted the volume of the nitrogen gas. So you're going to put the answer in the column for nitrogen. So under column. So in this example, it is column 3. You're going to use your volume calculation, okay, because that's what they asked for, guys. And you should get 6.72 as an answer. Just pause this quickly and then we'll carry on to the other example that's in your book. I know it's a lot to digest. I know it's a lot of theory, but I promise you, before you know it, you'll be doing this without thinking. In this example that we have here, which is on page 19 of your notes, hopefully you filled in everything else from the previous example. It's asking what mass of hydrogen is released when 5.2 grams zinc reacts with hydrochloric acid to form zinc chloride and hydrogen. So it's asking about the product, guys. It's asking about the product. It wants to know the mass of that product that is released after the reaction. So identify, before you do anything, I want you to underline the mass of hydrogen released, because that is the essential question. Step 1, we're going to write out our balanced equation. So it's going to be zinc plus 2 molecules of hydrochloric acid is going to form zinc chloride and hydrogen. If you can, I would actually write in the phases because it's just going to help you later on in test and exam situations. So perhaps make it a habit to write in the phases in your chemical reaction. Step 2 is write what you've been given underneath the relevant reactant. So what reaction gave us, what amount was given to us? 5.2 grams of zinc. So you're going to put that underneath the zinc. You're going to convert that to moles. So you should get a mole value of 0.08. So now you've gone from step 1 to step 3, and it's all under the zinc column. Guys, all under the zinc column. All right. Now we're gonna carry on with step 4 and 5. Okay. Step 4, you're gonna use that that mole value from your zinc. You know that the coefficient there is 1 to work out the mole values for the other reactants and products. So you should have a ratio of 1 to 1, 1. And this is why your balanced chemical equation is so important, grade 10s. If you don't have a balanced chemical equation, how are you going to use those coefficients later on for your mole value? So please make sure that that is right before you even carry on to step 2 or 3. Write this in quickly. And then the last one, this last step, is what they wanted to know. They wanted to know what mass of hydrogen. You're going to go underneath your hydrogen gas column, which is column 4 here, and you're going to work out the mass using your mole equation. So mass is equal to moles times molecular mass. Literally 0.08 times 2. You should get 0.16 grams. That's it, grade 10s. It's pretty, to me, it seems pretty simple and straightforward, but I think it's super cool. Obviously, I would. And I hope you guys do. You also think it's great. Please make sure that you filled in these examples on page 18 and 19. And the next time I see you, you guys are going to be left by yourself on your ACE, and I'm going to expect you to start working out your own stoichiometry without us holding your hands anymore. Okay, but as always, myself and Mr. Ginsberg are on the other side of the computer. If you need any help, you have any questions, just drop us a message. I hope you have a lovely day, and we will chat soon.